This lesson is composite function or composition of functions, sometimes it's called. And it says composite functions are formed from two functions when the output of one function is used for the input of the other function. That's the definition of a composition of functions. If you think about functions, and when you learned about functions, there are a series of inputs and outputs. You put something into the function, and it spits something out. Well, the way a composition of functions is going to work, you put something into one function, it spits something out, you put that into the other function and see what comes out. That's a composition of function. The output of one function is used for the input of the other function. And a composition of functions generally looks like either f of g of x, like that, or f of g of x, like that. It can be confused sometimes with multiplying functions, but that's not a multiplication sign in the middle. Right here, that's a little open circle, and that means a composition of functions. And that's probably the most common way that you would see it written, but I like this other notation because it actually kind of tells you what to do. It says take g of x and use it as the input for f of x. So it's kind of a nicer way to write it. Kind of makes more sense. But we're going to look at just two examples, and then I'm going to get you working on some of this stuff. So this one says, given f of x equals 4x, so there's the first function f of x. G of x is equal to x plus 6. H of x is equal to x squared. Determine each value. So it's giving us a whole bunch of different functions to work with, and it's going to ask us to find some things. The first one is f of g of 3. And if you remember the order of operations, the way brackets work, what happens when you have brackets inside another brackets? You do the innermost ones first, right? So if we're looking at that f of g of 3, the first thing that we're going to do is just this part, the g of 3. So figure out what g of 3 is. Well, that's probably pretty easy. What's g of 3? G of 3, well, g of x is x plus 6, so it's 3 plus 6, which means it's 9. So all I did was this part, the g of 3, and I left the f and the outer brackets still there. So they stay there. G of 3 is 3 plus 6, so it's 9. And now this tells us find f of 9. And f of 9, take the f function, which is 4x. So f of 9 is going to be 4 times 9, which is equal to 36, which means that f of g of 3 is equal to 36. For g of f of 3, we're going to find, so leave the g and the brackets and do the f of 3. F of 3 is 4 times 3 because you put the 3 in for x. So then it's asking us to find g of 12. Since g of x is x plus 6, g of 12 is 12 plus 6. So g of f of 3 is equal to 18. Different than f of g of 3. If you notice, the first one was f of g of 3 and the second one was g of f of 3. They're different. You can't switch the order and have them equal the same thing. To find g of h of negative 2, it's equal to g of, what was the function h? X squared. So negative 2 squared, which means it's g of 4. Negative 2 squared is 4. And then g of 4 is 4 plus 6. So g of h of negative 2 is equal to 10. And then the last one, it's f of g of h of 0. Just want to show you another way that that could be written, because I talked about these two different notations at the top. You would write that, you could write that as f of g of h of 0, like that. So just another notation, because when you get into the textbook, you're going to see both notations. So f of g of h of 0, leave the f, leave the g, evaluate the h of 0, which is 0 squared. So f of g of 0, right? Evaluate the g of 0. G of 0 is 0 plus 6. So we're finding f of 6, which is equal to 4 times 6, so 24. That's what f of g of h of 0 is equal to. Okay? Here's another question with composite functions, but it's a little bit different. This one we're looking at some equations and some graphs. So it says if f of x is equal to x plus 1 and g of x is equal to x squared, determine the equation of the composite function g of f of x and sketch its graph. So now we don't have an output, right? We don't have an actual value to input to get an output, so the output is just the function itself. So for g of f of x, it's equal to g of x plus 1. What will g of x plus 1 be equal to? Put x plus 1 in the place of x, so it's x plus 1 squared. Do you see how that works? The x squared, which is g of x, that x changes into an x plus 1, so it's x plus 1 squared. Well, what's that graph going to look like? X plus 1 squared, yeah? The purple line here is x plus 1, and the yellow is x squared, so that's f of x and g of x, and the black line is g of f of x. So it's the composition of those functions. It has an equation of x plus 1 squared. If we wanted to find a particular value, like f of g of, let's say, 2. No, let's not pick 2. F of g of 1, if we want to find that, we could do the same process by filling 1 into g and then that value into f, but if we have a graph of f and g, we should be able to do that, and I just want to show you how this relates to the graph. F of g of 1, we need to find g of 1, because remember this is f of g of 1 like this. So g of 1, if you look at the graph, the g function is the yellow one, and where it's equal to 1, well, we're looking at that spot, which is kind of large, but the function, what's the function value at 1? The function value means the y value. So when x is 1, what's y equal to? Also 1. So we found g of 1 from the graph, and so then that means we need to find f of 1. So look at the purple one. You should, is that f? Yeah, you should be able to find out what the value is there. Oops. At 1, it's equal to 2. So f of g of 1 then is equal to 2. And you'll be doing some stuff like that with graphs later, so we'll have a look. You'll have a look a bit more closely at that.